Hello and welcome! In the last video I repaired this Aztech Sound Galaxy Basic 16 sound card, which turned out to be great for DOS gaming PC, since it is actually 3 different sound cards in one. A Sound Blaster Pro 2.0, Windows sound system and Disney sound source. This sound card had a short and previous owner removed both voltage regulators, probably trying to fix it. However, the short turned out to be in a capacitor and I was able to restore this card to a more or less original state. Since it is such a versatile card, I was hoping to get a wavetable working on it as well. The wavetable header has a standard pinout, so the hopes were high. For the experiment I used the Sound Galaxy Wave Power wavetable, but I was not successful because this sound card unfortunately does not support MPU 4.1 MIDI standard, and so no general MIDI was possible. I tried other wavetables and also SoftMPU, but that didn't work either. Online I read that a very similar card, an Aztech Sound Galaxy NX Pro 16, was reported to support wavetable in DOS, so I dug through my to-do box and found a couple of broken NX Pro 16 cards, which were donated to my channel quite a long time ago. All 3 cards are mostly identical, one has a dark PCB, but technically they all look the same. As you see, the NX Pro 16 also looks a lot like the Basic 16 from the previous video. Some chips are even placed in a very similar order. This analog devices chip is responsible for the 16-bit Windows sound system compatibility, and the very same chip is also on the Basic 16 here. This Aztech chip is for Disney sound source emulation. Again, the same chip can be found here. And this one is the main controller, again on both cards. Also, both cards provide CD-ROM interfaces for Panasonic and Mitsumi drives. The biggest difference is visible in the analog part, which is responsible for mixing, filtering and amplification. The Basic 16 has separate voltage regulators, 5 volts for the logic ICs and 9 volts for the amplifier. The NX Pro 16, on the other hand, has only one 9-volt regulator for the amplifier. One part which stands out on the NX Pro 16, of course, is the expansion slot. The entry on the RetroWeb mentions that it could be used to connect SCSI expansion board, but I don't know if that is true, and I also never saw such a board, not even a picture. Maybe it never has been officially released. Now, as you see, the cards are almost identical, and the question is, would a wavetable work on an NX Pro 16? Some users say yes, but why doesn't it then work on the Basic 16? Let's first try to bring at least one of the NX Pro 16 back to life and then see how it goes. This first card seems to have a short on the 12-volt rail, similar to the one which was on the Basic 16 in the last video. These cards seem to have a common issue, so should you get your hands on one of those, check out the rails. Yeah, and as last time, also here we most probably have a shorted capacitor. And the ferrite bead has no continuity, exactly like in the case with the Basic 16. So on these cards I'll have to change the capacitor and the ferrite bead, then hopefully we will get a working card. Okay, let's take a look at the next one. Here we seem not to have any shorts on the regulator. The ferrite beads seem to be intact. The capacitor is not shorted as well. This card seems to have another issue. Here I can see a burn mark on a resistor which is connected to the middle pin of the voltage regulator. The middle pin of the regulator should be connected to the heat spreader, and it is. It also should be connected to the ground. And here we have no connection. Okay, that would mean that the regulator doesn't get the ground, and so it can't regulate the voltage properly. What would probably end up in non-working amplifier and a silent output. Here is obviously a burn mark. The inscription on the resistor is not readable anymore, but it should be just a 0 ohm protecting bridge. The resistor is still conductive, which is bad. The point of such a resistor is to protect the circuit from overcurrent. It should burn through before other parts or PCB gets damaged. In this case, it didn't work all that well. The trace between the resistor and the regulator burned through. That's unfortunate, and I'm not sure how this could happen. But hopefully no other parts were damaged on this card. So far, it looks like the trace has to be restored, and then we will see. Okay, next one. Here we have a shorted voltage regulator. Not quite, actually. It shows 9 ohm. That is not a complete short. Also on this card I can see a distinct burn mark in this area. As you see, the resistor and the capacitor don't look good. Here I get 9 ohm, but should have a resistance of at least into mega ohms. Let's check the ferrite beads. Those seems to be fine. The tantalum capacitor is not shorted as well, so it definitely is not the same problem as on the first card or on the card from the last video. Oh, this ferrite bead seems to be dead. I'm not quite sure, but it looks like this is going towards the game port. Maybe something was connected to the game port what shorted the 5 volts to the ground and killed the coil. Well, currently I have no explanation for what happened here. It looks like there was a big spark. Maybe a screw fell down on the PCB and shorted the parts. Hard to tell. Now, where we have an overview of all of the cards, let's start with this one first. For me, it looks like the most mysterious case. First of all, let's remove the burned parts and see if the short disappears. The best scenario would be if the small decoupling S&D capacitor is half shorted. Then it could be an easy fix. Well, without the burned SMD parts, we are still getting 9 ohms on the voltage regulator. The regulator provides usually 9 volts to the amplifier, which means that probably either the voltage regulator or the amplifier is dead. Maybe even both. Let's remove the voltage regulator first and test that. The regulator is out, let's see. We are still getting 9 ohms. That means that the amplifier is probably faulty. Yes, here we have a connection from the voltage regulator to the VCC pin of the amplifier. Well, let's remove the amplifier, I would say. Pay attention to the middle 4 pins of the IC. They are all ground and the IC is not socketed. The amplifier can get hot when working, and as you can see, there is a bigger ground plane underneath which is used as a heat spreader. That's why the middle pins are used to transfer the heat to the ground plane. This makes it complicated to desolder the IC. The solder pump is not able to fight against the heat dissipation of the ground plane. That's why it is important to heat up the PCB with a heat gun when removing the amplifier. Also, never forget to wiggle the pins before pulling out the IC. Don't apply too much force or you will rip off the solder pads and the traces. Okay, let's check once again. Did we find the culprit? And yes, we are now getting over 50 mega ohms. Means at least the amplifier was shorted. Yes, as you can see, there are 9 ohms between VCC and the ground pin of the IC. The amplifier is definitely dead. But what about the voltage regulator? Between the ground and the output pin there are only 512 ohms. That is too low, I think. Here I have a new 7809 voltage regulator. Let's compare the values. Here we have between the input and the ground pin 1.79 kilo ohm. Here we have almost 9 mega ohm. On the old regulator between the output and the ground pin, we are getting only 519 ohm. On the new one, there are over 27 kilo ohm. Of course, they are from different manufacturers, but the difference shouldn't be as huge. Let's see what a component tester says. Okay, the old one is detected as an NPN transistor, which is fine, I guess. The current gain is around 546 and the forward voltage drop is 500 millivolts. Those values are fine, to be honest. Let's see what a new regulator would look like. Almost the same values. This one is also detected as an NPN transistor. Well, I don't know. I don't trust the old regulator anymore. The resistance looks suspicious, but depending on the internals, that could be okay. Maybe the regulators just have different internal setup. What do you think? At least for me, 512 ohms between the ground and the output pin doesn't look right. Could be also a nonsense value, which could be due to internal parasitic capacity. Let me know what you think about it in the comments. But since the parts around the regulator were shorted, I don't trust it anymore and will take a new one. So, all the parts are back in place. Let's check the voltage. Here we should have 12 volts input. Well, 11.8, but it's fine. And here we get 9 volts, pretty much on point. Nice. Let's see if the sound card is actually working. Nope, it doesn't get detected. Neither by any game nor by the Aztech software. The card seems to be completely dead. I just tried to make some measurements and it turned out that the main chip got unexpectedly hot. Not like super hot, but quite warm, where on a working card this chip usually remains stone cold. Here I made some pictures with the infrared camera and as you see the chip went up to around 60 degrees Celsius. There are some other chips around which also look suspicious, like this Logic IC, which is definitely warmer than anything else around. The 50 degrees Celsius on the GAL is also a bit too much. Those ICs tend to get warm, but usually not over 50 degrees Celsius. I measured the resistance between the VCC pin and the ground on the main controller IC, and that seems to be also very low. For me it looks like multiple ICs are damaged on this card. The generic ones can be replaced, but the main controller IC is unique and is nearly irreplaceable. I checked the area around under the microscope once again and found some suspicious spots. First of all, this hair or something on the 74LS74 IC, which got so hot, looks like it's in the solder and was shorting 2 pins. Maybe it is some leftover from a thin wire which was burned in here, I don't know. Also nearby another burnt 0 ohm resistor from the ground. This one looks bad but seems still to be conductive. Just looks like a lot of current went through it. So my verdict is that this card is beyond a repair, mostly because the parts would be so hard to find. My assumption is that something has shorted the regulator and probably 9 volts from the output found its way through the ground into various parts of the card. What has potentially damaged multiple ICs? What a bummer, but maybe we will have more luck with another one. This is the second card with a similar damage. Here, as I said, a ground trace has burned through. Let's take a look under a microscope. Here it is, the trace from the resistor is toast and lifted. The resistor has obviously suffered a serious overheating. I measured it previously and it seems to be still conductive, but the marks are all burned off. Once again, the voltage regulator seems not to be shorted. I'm curious what actually has happened here. The regulator delivers 9 volts for the amplifier, but currently I'm a bit confused how ground trace could burn like this. Let's remove the resistor and take a look underneath. So I removed the resistor, and as you see, the trace which goes to the regulator is gone. The PCB underneath looks a bit burned. Unfortunately, also this pad is lifted. The PCB was exposed to a very high heat here. I probably could glue it back, but there is a wire nearby, so I'll better try to solder a wire there. This is that wire from the other side. You can clearly see a discoloration of the PCB around it. Looks like a lot of current shot through this point. I will try to replace the old resistor with a wire through this via. Here it is. That will not win a beauty prize, but should at least do the job. As I said, the old resistor was there probably for protective reasons, but it didn't hold the high current until the PCB has burned. Okay, looks like we have a connection to the ground here. Let's see if we have a working card. First of all, we have 9 volts on the regulator output. That is at least something. And the card gets detected. Very nice.
Sound Galaxy brings you into a realm of fantastic sounds. Computing will never sound the same.
Let's try a game. Doom works fine. Let's see if Wolfenstein 3D can detect the Disney sound source. And it does. Very cool. So, as I said in the last video, the Sound Galaxy Basic 16 doesn't have MPU 401 support, so this card is not able to provide general MIDI sound, and although it has a wavetable header, it's kind of useless in DOS games. Or is it? The NX Pro 16 is basically the same card, with same chips, so it shouldn't have MPU 401 either, and I confirmed it with some tests. However, As I mentioned in my last video, I tried SoftMPU, a tool which emulates MPU 401 in software. I tried it on the basic 16 with the Sound Galaxy Wave Power and didn't get any MIDI sound out of it. However, I saw reports that it should work on the NX Pro 16, so let's see if it is true. SoftMPU needs an expanded memory manager like EMM386 or QMM to work. The arguments are simple. You set on which port MPU should be emulated and the setting of your Sound Blaster card where the sound will be redirected to. The standard MPU 401 port is 330 and my sound card is at port 220 and interrupt 7. SoftMPU should be able to provide Roland MT-32 compatibility, which was supported by some later 80s and early 90s games. For example, Monkey Island. It has a list of supported audio options and we need the option R for Roland. Haha, and we have MIDI sound. Awesome! Well, it sounds nothing like an MT-32, but it is definitely wavetable MIDI sound which we get. Nice! Let's try another game. King's Quest also supports Roland MT-32. Let's give it a try. And also here we have MIDI sound. Cool! Unfortunately, all games which use protected mode will not work with SoftMPU, but there are already modified versions of SoftMPU which should make it possible. I'll take a look at it another day, but now I'm confused why does NX Pro 16 works with SoftMPU and the basic 16 doesn't. So I went through the tools and utilities of both cards and compared those. They are mostly the same. Actually, I can use NX Pro 16 tools and drivers with the basic 16 and the other way around. No wonder the cards are almost identical. But there is one thing which caught my eye. Here on the left we have the utilities of the basic 16 and on the right the NX Pro 16. As you see, the set is nearly the same. The interesting tool is sgp16vol.exe, which is used to set the volume of different channels. As you see here, we have microphone, volume, CD, FM, and so on. If I set master volume to maximum, the card will list current settings. Oh, volume can be set separately for left and right channel. As I mentioned already a couple of times, Aztech was quite progressive for its time. So here we see, for example, FM volume at 15, master volume at 15, and so on. Everything looks fine. Now let's take a look at the options of the same utility for the basic 16 card. Here I noticed that it has a separate setting for the wavetable volume. As I set the master volume to 15 to see the other settings, it showed up that the wavetable volume is turned all the way down to 0. And as I set it up to 15 as well, suddenly the MIDI sound came out of the speakers, just as it did for the NX Pro 16 previously. So the basic 16 actually worked. The wavetable volume was just turned down. Or as you can hear, also Prince of Persia supports Roland MT-32 and it works with this card using SoftMPU. This game is also a nice test case, because it doesn't only support Roland MIDI for music, but also Disney sound source for the digital effects. And so this game can be enjoyed with good sound outside of mainstream Sound Blaster option. Well, kind of, since SoftMPU utilizes Sound Blaster port for MIDI redirection, but at least from the game point of view, Sound Blaster is not involved. I tried a couple of different games and some did sound okay, but most of the games did sound very odd. For example, Gods, which also shows a nice text about Roland card initialization, sounded promising in the intro. However, the sound in the game itself was a disaster. I don't know what's wrong with it, but I know that the game is extremely timing sensitive and doesn't run well on fast CPUs. My capturing machine is a Pentium 2, which could be just too fast for this game, and I'll have to try it on a slower PC later. But I have to admit that all of the games I tested didn't sound perfect using wavetable through SoftMPU on this card. I will do more experiments later, but if you tried it in the past, please share your experience in the comments. And in case you already forgot, this is the third card on my to-do list today. Off camera I already replaced the ferrite bead on the capacitor and I tested the card and it's fully working. I decided to skip the details because it is absolutely identical issue as the one which was on this basic 16 card and which I fixed in the last video. If you are interested and didn't see that one, feel free to take a look. And today's video is already quite long, so it's time to summarize. I was able to repair 2 of 3 Sound Galaxy NX Pro 16 sound cards. As I already mentioned, this one had the same issue as the basic 16 from the last video. The culprit was a shorted tantalum capacitor, which is a very common issue on hardware of this age. These two cards had a very similar problem too. On both cards it looks like too high voltage or reverse voltage was applied. I'm not sure how that could happen, but my theory is that on both cards something wrong was connected to the output. The audio port has a common ground connection which goes to the other places of the card. Maybe 12 volts or 9 volts were inserted here, what has ended in negative voltage on the 5 volt rail. I don't know exactly, but this could be the explanation how the chips on this card could have been damaged. And this is very sad, by the way, since this card is basically beyond repair. Luckily, this one is still working though, and I think 2 of 3 is still a good result. And, well, this card can be still used as a donor for another hardware, so nothing gets wasted. And I hope you enjoyed this repair today. Thank you for watching, and goodbye.